Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
When you buy a premium fragrance, you're paying for an illusion. You're paying for the marketing, the celebrity endorsement, and the heavy glass bottle. But inside that bottle, that is pure, highly calculated chemical engineering. Welcome back to Simple Gyan. Today, we are taking a massive, deep dive into the $40 billion global perfume industry. We aren't looking at the fashion, we are looking at the factory. If you've ever wanted to know exactly what it takes to build a perfume manufacturing plant from the ground up, from the zoning laws to the exact stainless steel machinery, the chemical raw materials, and the profit margins that make this one of the most lucrative industries on Earth, you are in the right place. Grab a notepad. Let's engineer a fragrance empire. Fourth, the fragrance compound. A blend of natural essential oils and synthetic aroma chemicals, which are the stable backbone of modern manufacturing. Before we pour a single drop of ethanol, we need to understand the board we are playing on. The global fragrance market is massive, expected to cross $60 billion by the end of this decade. But it is heavily segmented. You have three main tiers: mass market, designer, and niche. Each has vastly different volume requirements and profit margins. The global supply chain relies on natural extracts from Madagascar, vanilla, and India, jasmine, combined with high-tech synthetic aroma chemicals. If you are setting up a plant today, your target market dictates your entire factory layout. Are you pumping out 100,000 bottles a day or 500 bottles of premium extrait de parfum? You cannot just rent an empty warehouse. Fragrance manufacturing is, fundamentally, the handling of highly flammable liquids. Site selection is critical. Because perfume is typically 70% to 90% ethanol, your facility is classified as a hazardous environment. Your ethanol storage must be heavily regulated. Every electrical component on the mixing floor must be ATEX certified, explosion-proof. A single spark from a standard light switch can ignite alcohol vapors. HVAC systems require negative pressure ventilation in the mixing rooms. This pulls fumes out through scrubbers so workers don't pass out and scents don't cross-contaminate. Now, let's talk hardware. Perfume is acidic and corrosive over time. Every mixing tank must be pharmaceutical-grade SS316L stainless steel. These tanks need pneumatic, air-driven agitators to stir the mixture without electrical sparks. This prevents any metallic reaction with delicate aroma chemicals. After mixing, the liquid must be flash-chilled to around 0 degrees C and passed through microfilters. This is the secret weapon of clear perfume. For high capacity, you need a rotary vacuum filling machine. These ensure every bottle is filled to the exact same visual height, regardless of glass variations. Perfume isn't screwed shut, it's crimped. A pneumatic crimper permanently seals the pump, ensuring the alcohol cannot evaporate and oxygen cannot get in. What is actually in the juice? First, the solvent. You will use SDA-40B, which is specially denatured ethanol to bypass heavy beverage taxes. Second, the water, not tap water. You need demineralized, DM or reverse osmosis, RO water, to prevent calcium and magnesium from clouding the liquid. Third, the fixatives. These are heavy molecules like ambroxan that anchor the scent to human skin, so it lasts 12 hours instead of 10 minutes. Fourth, the fragrance compound, a blend of natural essential oils and synthetic aroma chemicals, which are the stable backbone of modern manufacturing. Industrial process. Step 1, compounding. Raw fragrance oils are pumped into the SS316L vessel, and denatured ethanol is added slowly while the agitator spins. Step 2, maceration. The mixture must sit in dark vats for 2 to 4 weeks. This allows molecules to bond chemically, smoothing out the alcoholic bite. Step 3 and 4, chilling and filtration. Flash chilling forces waxes to solidify so they can be filtered out, making the liquid crystal clear and stable. Finally, the juice is filled, pneumatically crimped, and packaged in cellophane-wrapped boxes, ready for the global market. At the top, you need a master perfumer or a lead chemist. A chemical engineer is essential to oversee the complex mixing and maceration process. Quality control technicians use GCMS machines to ensure every single batch matches the chemical signature of the master sample perfectly. Let's talk numbers. The gross margins are unbelievable, but the initial capital expenditure, CapEx, is brutal. You need serious investment for ATEX safety. The liquid inside a $100 bottle usually costs $150 to $4 to make. The packaging, glass bottle, and magnetic cap often costs more than the perfume itself. Marketing is the invisible cost. Up to 40% of revenue is pumped back into marketing. Once you break even on machinery, the scaling is highly lucrative.